Today we are going to discuss wavy curve method. So let's see what is this wavy curve method. First thing that we are going to discuss is interval. Interval means if I write in this form that x belongs to less than or equal to b, more than or equal to a, then you can easily understand. So the same thing we can write it as, we call it as a closed interval a to b. X belongs to a to b. Similarly, if we have a case, this is the first case, if we have a case like a, x and b, x lies between a and b, the same information we can write as x belongs to a, b, open bracket. Here a and b are not included, so this is called open bracket, open interval, and this one is closed. We may have a situation when one part is equal, a, x, b. This can be represented as x belongs to closed a, open b. Or if we have a, x less than equal to b, then we can represent it as x belongs to a, b. Sometimes we also represent this one as a, b, and this one as a, b. So this is the interval which a student must know, because we are going to discuss the final result and the options will be in this form only. Now let's see the Cartesian coordinate plane. You all are aware that this is your x-axis, this is your y-axis. It has divided the entire plane in 4 quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Now in first quadrant, you take any point here. If you find the coordinate of x here, it is 4, 1, 2, 3, 4 means, and coordinate of y is 1, 2, 3, 4, 5. So coordinate of this point is 4, 5. So you take any point in this quadrant, both x coordinate as well as y coordinate is positive. Both of them are positive. You take any point in this coordinate. X coordinate is this one for this point, which is negative direction. 1, 2, 3, 4, 5, 6, 7 and 8. 8 point. So minus 8. So coordinate of this is x coordinate minus 8, y coordinate 1, 2, 3, 4. 4. So mainly if you take any point in this quadrant, then x coordinate is negative and y coordinate is positive. Now let's see in the third quadrant. You take any point in this quadrant, its x coordinate is also negative and y coordinate is also negative. So both of them are negative. In fourth quadrant, if you take any point, say this point, then x coordinate is positive but y coordinate is negative. So positive, negative. This is very important. So again I will tell you, in first quadrant both x and y are positive. In second quadrant x is negative, y is positive. In this quadrant x is negative, y is negative. In fourth quadrant x is positive, y is negative. This is very important and I do believe that most of you know this. Move to the next one. Again I'll insert a graph paper here, coordinate grid. Now let's suppose if I give you a graph, this is very important, students, please pay attention. If I draw a random graph like this, and if I ask you, say this is the graph of y is equal to fx, function of x, and if I ask you at x equal to this point, coordinate of this point is 1, 2, 3, 4, 5, 6, 7. So if I ask you f of minus 7, it is positive or negative. So you will calculate f of minus 7 means what is the value of y? This value. This value is y is positive. It is approximately equal to 2.5. So you will tell me it is positive. So basically you take any value of x in this range, y is always positive. Y is always positive. You take a value x here. What is y? It must be negative here. It must be negative. Must be negative. At x equal to 0, what is the value of y? Positive or negative? It is negative. At this x equal to 1, y is f1. Now tell me f1. Is it positive or negative? It is definitely positive or negative. Tell me. At 1, it is in fourth quadrant. X is positive, y is negative. So you take any point in this region, x, any value of x, y is always negative. Again, if you take any value of x in this region, y is always positive. You take any value of x in this region, again it is negative. And any value in this region, it is again positive. Let's see this by one example. Let's see this by one example. Say I am drawing a graph like this. This is A, this point A, this point B, this point C, this point D. So now tell me one thing. If I take x, any value of x between minus infinity, infinity and minus infinity is always with the open bracket. Minus infinity to a, fx, the value of y is always positive, always positive. If you take any value of x between a and b, any value of x between a and b, this value, this value, this value, this value, it is always negative, because y is negative here. Why? Because if you take this value of x, then value of y is this one, which is negative. Now you take any value of x between b to c, between b to c, any value of x between b to c, it is always positive. You take any value, it is always positive. You take any value of x between c to d, it is always negative. And you take any value of x between d to infinity, again it is always positive. So if I ask you, find the value, with this graph is given to you, find the range such that fx is less than 0. Fx is less than 0 means what? Fx is negative. So negative is in which all region? In this one it is negative, and in this one it is negative. So to solve this one, answer you will write as x belongs to a to b union c to d. So this is the basic concept of method of interval or wavy curve. Once you understand this, then we can proceed on different types of graph. So first of all, let's see a simple one. If I give you only one factor, y is equal to x minus 2. All of you know this. This point is 2. So if you take any value of x before this, in this range, always y is negative. And if you take any value of x in this range, y is always positive. Not only this, if you plot the line of this, the graph, it will be something like this. So you take any value of x in this region, y is always negative. If you take any value of x in this region, y is always positive. So if I ask you that x minus 2 is positive, then what you will write? X must be more than 2, means in this region. If I ask you x minus 2 less than 0, then you will write x less than 2, means in this region. So this is the case when we have only one factor. Now let's see when we have two factors. Let us suppose if I give you a graph or function y is equal to x minus 2 into x plus 2. So it has two zeros. One zero is x equal to 2 and the other is x equal to minus 2. So if you plot the graph of this, it will be something like this. It should pass through these 2 points and something like this. Graph is something like this. So if you take this value of x, then y is positive. If you take this value of x, y is positive. Y is positive. If you take this value of x between -2 to 2, then all the values y is negative. And if you take any value of x after 2, then it is always positive. So if I ask you a question that y is, or x minus 2 into x plus 2 is more than 0, then your answer should be x belongs to minus infinity to -2 union 2 to infinity. Or if I ask you x minus 2 into x plus 2 is less than 0, then your answer should be x belongs to -2 to 2. What will happen at x equal to 2 exactly? Y will be 0. X equal to -2, y will be equal to 0. Now let's see why this happened. Consider y is equal to x minus 2, or x plus 2, let me write first, into x minus 2. That means there are 2 points here. One point is -2 and one point is here 2. Now let's see each of the factor one by one. First of all, tell me x plus 2. Tell me about x plus 2. X plus 2 is negative here. It is negative here, bit less than -2, and is positive in this range. While if you consider the next one, which is x minus 2, then x minus 2 is negative in this range and is positive in this range. So now combine these two, x plus 2 and x minus 2. Combined, y is equal to x plus 2 into x minus 2. And see the condition when x we are taking less than -2. When we are taking x less than -2, then this one is negative. This factor is negative here. And this factor is also negative. So the overall it is positive. Next, between -2 to 2. This I have taken when x lies between -infinity to -2. The next range is -2 to 2. Between -2 to 2 means in this range. In this range, the first factor is positive because after this it is positive. So this will be positive, and this factor between -2 to 2, the second factor, this one is negative. So the entire product is negative. Next is between 2 to infinity. Between 2 to infinity means after this one. In this region. In this region, this factor is also positive. This factor is also positive. So positive into positive must be positive. So if we move to the, let's move to the next slide. Let's see this. So if I erase some of the calculation. So finally what we can conclude here is that like x plus 2 into x minus 2. So this is -2, this is +2. In this range it is positive, in this range it is negative, and in this range it is again positive. So positive, negative, positive. And hence if you draw the graph, it looks like this one. So I think you have understood the graph of when we have two factors. Let's see when we have one more example when we have two factor. If I give you, plot the graph y is equal to x plus 3 into x plus 4. So first find the zeros of this. Zeros are -3, and minus 4. These 2 points only. So if you plot the graph, it should be something like this. That means if you find the sign scheme of this, it is positive here, negative here, positive here. Let us see one more, or let's see in general case. In general case, so if I give you y is equal to x minus a, y equal to x minus a into x minus b. Anywhere I can take a and anywhere I can take b. So simple sign scheme of this is, it is positive in this range, negative in this range, and positive in this range. Reason we have already seen. In this range it is positive, in this range it is negative, in this range it is positive. If you want to plot the graph will be something like this, parabolic curve. Now let's see when we have 3 factors. So let's consider with 3 factor. Y is equal to x plus 5 into x plus 1 into x minus 3. So in this case we have how many zeros, how many change points we have? One point is minus 5. 1, 2, 3, 4, 5. Minus 5. One point is this. Another point is minus 1. And the another point is 3. So these 3 are the change points. These 3 are the roots or zeros of this function. So when you plot the graph, let's see. First of all, x plus 5. X plus 5, if you look at carefully, x plus 5 is negative here and positive here. This is for x plus 5. If you look at x plus 1, then x plus 1 is negative here and positive here. This I have written for x plus 1. Then see x minus 3. X minus 3 negative here and positive here. This is for x minus 3. Now if you combine all the 3, means if I write y is equal to x plus 5, x plus 1, x minus 3, then the first reason that we have is this one, less than minus 5. In this region, this factor is negative, this factor is negative, this factor is negative, so the overall we will have is negative. Next is between this minus 5 to minus 1. Between minus 5 to minus 1, this factor is positive, the first factor which is positive. The second factor is still negative, and third factor is definitely negative in this one. So the product is finally positive. Now next reason is between minus 1 to 3. This one. In this region, this factor is positive. This factor is also positive, while this factor is still negative. So the overall we will have is negative. Now let's see when it is more than 3. So first factor is positive, second factor is also positive, third factor is also positive. So overall it is positive. There are 4 regions and this is the graph. So let's move to the next and let's see. The first region less than minus 5, it is negative. Between minus, so let me write here, this is between minus infinity to minus 5. This one is between minus 5 to minus 1. This is between 1 to 3, and this is between 3 to infinity. Now let's see. Let's move to the next slide and plot the graph of this. So let me erase these things first. So we need to plot the graph of this now. So when you need to plot the graph of this is the function, and you need to plot the graph of this. So first thing that you should do is find the change points. We have already calculated the roots. X equal to minus 5, 1, 2, 3, 4, 5. So 1 is this one. then minus 1, 1 is this one, and the next is 3 is this one. Look at carefully from this one, 3 to infinity, it is positive here. Between 1 to 3 it is negative here, it is positive here, and it is negative here. So negative, positive, negative, positive. Here it is in this range, it is positive. Between 1 to 3, sorry, this is minus 1. This would be minus 1. Minus 1 to 3 it is negative. So if you want to plot the graph of this function, you can easily plot the graph now, because you know the sign scheme, in which sign it is positive and in which one it is negative. So you can plot the graph. So let's see the graph of this. Graph of this is, it is positive in this region, negative here, positive here, again 5 it is negative. So the graph of y is equal to x plus 5 into x plus 1 into x minus 3 is as shown. That means between any region between minus infinity to 5, y is always negative. Now if I ask you a question that find the region such that this is negative, then what answer you will write? Answer you will write is negative in this region. In this region means minus infinity to minus 5, union, again it is negative in this region, union minus 1 to 3. So this is the answer of this inequality. Now let's see most generalized case. If I give you y is equal to x minus a into x minus b into x minus c, 3 factors only. A, B, C can be positive or negative, anything. So I am assuming a here, b here, and c here. So if you look at the sign scheme of this, it is always positive here, negative here, positive here, and negative here. Not only this, if you plot the graph is something like wave, something like this. This is the graph. It will cut at this point B. And if I ask you in this question that find the value of x such that this is more than 0, then in answer you will write more than 0 means positive, means in this region it is positive, in this region it is positive. So answer that you will write here for this, x belongs to a to b union c to infinity. Let's move and so let's see if we have 4 factors. So consider y is equal to x minus a, x minus b, x minus c into x minus d. I am assuming a here, b here, c is here, and d is here. Always sign scheme, right hand side, the rightmost part, this part, it is always positive. Then keep on changing the sign. This is positive here, so this one must be, this region must be negative. Then this region it is positive, this region it is negative, this region it is positive. So positive, negative, positive, negative, positive. And if you want to plot the graph of this, positive means it will be something like a wave, so we call it as a wavy curve method. This will pass through C, this will pass through D. So this is the graph. And if I ask you a question that this is less than 0, find the value of x. So you will say less than 0 means it must be negative, so in this region, and x should be in this region. So the answer is x belongs to A to B union C to D.